For this video, I'm going to solve another problem about simple stress, particularly on normal stress. Here's the problem. Determine the largest weight, W, that can be supported by the two wires EB and EC. The working stresses are 120 megapascal for EB and 180 megapascal for EC. The cross-sectional areas of EB and EC are 300 millimeter square and 150 millimeter square respectively. So first thing to do is to cut sections cables EB and AC and identify the forces. So for EB, we have tension AB, and then tension EC. And then we will draw the free body diagram. So weight downward, and then TEB, second quadrant, direction of 30 degrees. TEC, first quadrant, the direction is 45 degrees with respect to horizontal. So in order to have an expression of TEB and TEC in terms of W, we can use the conditions of equilibrium. We can sum force along the horizontal and along the vertical. We can do that. Or we can use force polygon since there are only 3 forces. And so therefore we can have a triangle since we only have 3 sides. So let's start with W, downward, and then connect the EB, second quadrant, and then connect the EC. So we have this triangle. Next is to determine the interior angles of the triangle. Now let us start with TEB. The direction of TEB with respect to horizontal is 30 degrees. So therefore, this interior angle is equal to 60. Similarly for EC, TEC, its direction from the horizontal is 45 degrees. This one, 45 degrees. So this interior angle is equal to 45 degrees. And in a triangle, the total interior angles is 180. So solving for this angle, it's 180 minus 60 minus 45. And the value is 75. So next is to perform U sine law, so that we can get the expression of TEB and TEC in terms of W. So sine law, one side over sine of opposite angle, and then same with the other side. So ratio sa side over sine of opposite angle. TEC over sine of 60 degrees equal to W over sine of 75 degrees. And TEB over sine of 45 degrees. So let's combine this one. And solving for TEC, let's cross multiply sine 60 to the right side. And so we have this one. Let's compute the value of this. Sine 60 over sine 75. The value is 0.8966 W. We do the same for TEB. So let's cross multiply sine 45 to the left side. We have this one, and then compute for this value. Sine 45 over sine 75 degrees. We have 0.732. Now next, we have given values for the stress of EB and EC as well as the projectional areas. So therefore, we can solve for TEC and TEB. And with those values, we will have 2 values of W. And from the 2 values, we will select the largest. Okay. First, let's consider EC. If The stress of EC is 180 from this one. If the stress of ET is 180 is, our stress of EC is 180 megapascal. Now, stress is force over area. Okay. Millimeter squared is cancelled out. So, TAC is equal to 27,000 newtons. Now, from this value, 27,000, we can substitute this one to this expression. So, and then this value, 27,000, let's divide it by 0.8966 and we have this W. So weight is 27,000 over 0.8966. And the answer is this one, 30,113.76 newtons. Now, let's try AB. Okay, the stress of AB is 120 and the cross-sectional area is 300. 120 and area of 300, TAB is 36,000. And the next is we will substitute this value to this expression. So 36,000 divided by 0.732. We have another value of W. Now, between these two values, which value is the largest? Now, normally, without thinking, okay, they will select this one, 49,180.33. Now, but the correct one is the smaller value between the two, which is this one, 30,113.76. It's the largest safe value. That is the smallest value, okay? Not the biggest one. So this one is the largest, okay? The reason is this. Now, if we use this value, okay, for EC, of course, 30,113.76, okay, divided by 150, we will have 180. No, 30,113.76 for EC, if we substitute this value to this expression, we will have a tension of 27,000. You divide by 150, that's 180. Now, if we will use this value for EB, 30,113.76 Newton times 0.732, we will get a value of TEB less than 36,000. Okay? 30,000 times a value less than 1. It should be less than 30,000. So that value, if you divide 300, the resulting stress of EB is less than 120. So it's very safe. But if we will use this value for EB, of course, the stress is 120, no? 49,180.33. This is EB. Okay, if we will multiply this one by 0.732, 40,180.33 times 0.732, the value of TAB, of course, is 36,000. And if we divide it by the cross-sectional area of 300, the stress is 120. But if we will use this value for cable EC, 49,180.33 times 0.732, 0.8966 for EC. The value of TAC will be bigger than 27,000. 49,180.33 times 0.8966. The value is bigger than 27,000. So if that value will be put here, and then divide by 150, the resulting stress of AC is bigger than 180. So it's no longer safe because 180 is the maximum allowable value of cable AC. Therefore, this value is not safe. So the largest safe value should be 30,113.76. So I hope that you have understood this my explanation of this one, and I hope that you enjoyed watching this video. Okay, thank you, and God bless everyone.